Deze moet ook iets zachter. Chris. Chris. Deze moet ook iets zachter. Test, test, test. So,
Yes.
I have a headset for you.
Okay, thank you. Like that or?
I don't know. It's set down.
Yeah. Yep.
And then maybe you can put it in your back pocket.
Perfect. Thank you.
Are you ready?
Yeah, for me it's okay. I think I will take out this.
I can start whenever you're. Tell me when you're ready. Good evening, everyone. Welcome to this evening's lecture entitled Engineering Architecture and Vice Versa by Roy Furtado. This is lectures part of the Berlage Keynotes, our ongoing lecture series featuring internationally prominent architects, designers, and thinkers who are at the forefront of design, innovation, and discourse. Roy has studied architectural engineering at Oporto University and in 1985 co-founded AFA, where he combined structural design and project management with teaching at the university. His professional career has allowed him to develop a wide view of engineering, believing that in a moment where buildings are increasingly more complex, the broader contribution of the engineer lies in exploring the potential of multidisciplinarity and interdisciplinarity. He has aligned his structural engineering knowledge with a special perspective on architecture and innovation. While a designer, he's motivated by the search for successful integration of all the components of construction. This way of practicing engineering is reflected in most of his projects, in most of the projects he's led, such as the Braga Municipal Stadium, the Casa de Musica in Porto, and more recently, the Elmu Museum in Lausanne. It is fantastic to have you here to present maybe another side of some of the buildings that we know. Thank you.
Okay. Well, first of all, well, I apologize for being an engineer, but in fact, I think this fight between architects and engineers in the past is quite dumb, because actually the best results are always obtained with cooperation and, as Solomon was saying, with multidisciplinarity and interdisciplinarity. And the projects in my life, the projects where we went further were in terms of result. And for instance, I'm recalling the Braga Stadium, is when the architect loses control of the techniques of doing it. And it's very interesting. For instance, the Braga Stadium, the change in scale from what Eduardo was doing before and in that project made him be, well, to draw something, you'd need me together. So at the end, it was something very, it was a very strange process, but a very fulfilling process in terms of cooperation. And it's funny that at the end we did conferences where he would explain the engineering and I would explain the architecture, which was in fact the whole process brought us there. And I think this is something that is, for us engineers, of course, and I think also for architects, it's very enriching, and the result can really go further, because in fact the ideas coming from several fields of knowledge and from several perspectives can in fact improve the quality. Well, but I have brought here 4 projects built and 2 not built. I don't know what time we have. The presentation is long, but I'm going to accelerate in some parts. But what I wanted to show you here is really the complexity of a modern building, and what you have to do to make everything work together. Because the more complex are things, the more complex are installations, the less space you have for them. All that needs really an integrated approach to the design from everybody, from the architects and from the engineers. And so the first project I'm going to show you is the Museum of Art and Architecture, the MAAT, done with the office, the London office, ALA. Well, it's by the river by the Tagus River in Lisbon, so it's a wonderful place. And this was, I'm going to show you the ambition, the initial ambition of the project. And when Amanda came to Portugal to present the idea, this was the idea. And, something happened. Maybe it's the idea that is not, well, clearly something happened. Finished? Well, thank you very much. You can... Something happened, but I don't know what it was. Is it my computer that is not working? This is... Okay, now it's showing the wrong one, but it's okay. Yeah, but it's showing the... Okay, no problem, but... well, you will see it anyway, so, okay, let's do it. So, this was the idea. Definitely it doesn't like the project. I will change the project. Maybe it...
Maybe we can try another.
Yes. Okay.
See if that works. Wrong way around.
No.
Yeah. There it is.
Yeah.
Okay.
Stay. Okay, let's see. Okay, so this was the idea. As you can see, it's a quite organic building. And when they arrived, they had... the concept of the building is quite fluid, as you can see. But because of the structure, there is a big span. The roof has a big span over the main room, which is the oval room. And I don't know if you know, if you have been there, but it's there's an oval room, a big oval room where everything, the major exhibitions happen. This one, but the original structural design would have these triangular columns inside. Because the problem, as you can see, is that there is a big cantilever. It's around 25 meters cantilever. Then you have that span. So the original design came like that. Obviously, Amanda was not happy with the columns in the center of the room, but there was not any alternative, and so we decided to study a different approach. And so we proposed to have a big truss in that alignment, that is a curved alignment, but with that big truss, we would, and these trusses, we could take out the columns of the room. And obviously everybody was quite happy with it, And we were also happy with that achievement. So this was the big truss in front of the building and the room with no columns. But the question was that afterwards, well, they did the renders and they discovered that the truss was in fact the teeth of the shark. And obviously everybody began saying, oh my goodness, we can't do that, it's too obvious, we can't do that. And they said, Christ, what do we do now? if not even the teeth of the shark are allowed, what can we do? Then we began again, and with the shape we discovered that there was one place where we could, in the shape of the building, where we could use an arch, a big arch, that could take care of and support the cantilevers. And so, well, this is the architect's interpretation, and actually it's more than that. It's really to see if it fitted in the shape and if the shape would need something. And that's how it was done at the end. It was done with this big arch. You will see some pictures afterwards. With this big arch, and by doing that and changing the structure that way, we were able to free the mouth of the shark and, of course, the interior of any supports. So this is a section done in the model where you see the oval room with no columns. The only support that we have is this one, and then you have the 25 meters span until the bottom of the cantilever. So this was the main thing. Of course, a building with such a geometry is always a big challenge because geometry rules everything. But because of the height of the structure you need to do such a thing, services are not a problem. They fit everywhere, so it's not a big deal. So that's why they're not represented in this presentation. Well, this is just for you to have an idea of how the technical drawings needed for the arch, and some pictures of how the arch has been built. Such an arch, as you have seen, the arch is around 85 meters. The span is 85 meters and 14 meters of height. So it's big. So to build it, you need to have temporary supports that afterwards are allowed to connect the several segments of the arch. And here already the arch already being finished. The other challenge here in this process, okay, some more pictures. I will go a little bit further. And the arch here, and this is the interior of the room during the construction and finished at the end. This is another room. It's the room beside the big oval room, which has also that skylight, and that was also something interesting from our point of view. The other part that was interesting here was the facade, because this smooth facade would need a material that could do the facade without many, well, cuts and things. So it's a ceramic facade, and the ceramic facade, the problem with the ceramic facade is that it requires a very specific structure to support it, because, and that's what you see here, those small structures are all the structure that makes the first approach to the surface. The surface is you get that surface in several steps if you want. You have first the big structure, then you have a second structure that approaches the final surface, and then with the tiles and the regulation of the tiles, you put you get the final surface. That was it. And so here, just for you to to have an idea of the facade structure, which is massive, as you can see, not so strong, but massive in terms of, because you need a lot of points to support those tiles. Okay, some pictures of the rest, and that's it. This is the model of the air conditioning and so on. And just to show you finally, there was at the end an overpass, a pedestrian bridge to connect the building with the city on the other side of the motorway, let's say. And some pictures of the end result. And I think that's the one. Okay, so I moved to another building, completely different. That one was a museum, well, kind of museum, gallery museum. This one is an office building. This one was done with Manuel Aires Mateus, and it was a competition that we won together. And basically, it's the headquarters of the electrical company in Portugal, the main electrical company in Portugal. So the idea here, as you can see, is that the river is on your left, and the whole city has been built in lines perpendicular to the river. And that is because not only of sight, but also of winds, so that the wind could ventilate the whole I'm sorry. Oh, okay, it's fine. So the idea and since the beginning, okay, let's go along with that idea and have two separate buildings parallel and make the connection underground between the two buildings. So this was it. Here you have the competition model also. And okay, so the question afterwards, and here it's really the architecture working, is that you needed two ramps for the car park. So Manuel had this idea of going up in both sides in opposite places, going up so that the ramps could get in. And that's the reason why you see those two places where the building doesn't touch the ground, because that's where the cars enter. Of course, this creates some difficulties, as you will see. Just an idea, you have the buildings, then you have there the -1 that does the connection between the two buildings, and that's where you have auditoriums, cafeteria, and so on. And then you have car park below. A transversal section showing exactly the same thing. Underground car park and first floor. This is really the connection. On the ground floor, what you have is a big plaza, or public plaza. Everybody can go. But then you have these two stairs where you go down. And when you go down, you go to the reception if you want. And then you are distributed by the 4 cores that are 2 in each building. This is the square, the public square that you can cross in the city, and the upper floors. These buildings are 12 meters wide, and that's it. Okay, so coordination, of course, the question is all about coordination, integration to avoid surprises, and to be able to put everything in. This building had a problem. It is 7-story high, and it had a level that we couldn't go over. To put all the surface that was needed, in a 12-meter building, because if you begin increasing it, you'd reduce the plaza, so it was not so interesting. So the idea was to keep them not so wide, and then we have 7 stories. But the problem is that to have 7 stories, we had to compress the package of slab and services. So the question was, how can we do that, knowing that it's the headquarters of a big electrical company? So they want everything, they want the comfort, they want everything that you want, that you can imagine. So the big challenge in this project was also to be able to put everything inside that space. What you see here is obviously a Revit model of the installations, exactly to understand how they could fit, and the solution for the structure, that was to have these trusses, very light trusses, but for the 12 meters, but well, because they are light, there's a lot of freedom in terms of passing the ducts and so on. What happened is that to be able to have small ducts, you have to distribute the shafts so that you don't have big lengths. So there is all a global reasoning for that, to be able to have small ducts, as you can see over there. What you see in the middle is that because the height was so small, we had to use the height over the pavement, the height for the structure, for the truss. So what you see there is that the slab is on that line, on that L that you have there, and only the lower part is beneath, and the rest was covered by the false pavement, for the raised pavement, as you will see in a minute. So this was just a render of the concept. These trusses are spaced 2.4 meters. So the hollow rib plates, you don't need any more structure. So it's only the trusses and the hollow rib, so that you could always keep the structure at its minimum. Again, these installations, and this is, well, here you don't see it very well, but this is the installation at the end. It's really that. There's nothing you can fit in that space. Everything goes perfectly, but it's the maximum you can have. You can't have anything more. Okay, for the structures. Okay, that was the main drive for this project was really this one: lightweight, everything as small as possible, in a way that you can't identify exactly what is structure, what is not structure, and so on. And here we have the result. What happened also is that we didn't want to have columns in the facade, not even in the offices. So the columns would have to be in the facade, outside, but they shouldn't be seen. So what we had to do was to have as much columns as possible in order to have them the smaller possible and disguised in the facade. And so we've established a size of 10 by 20, rectangles of 10 by 20, or hollow rectangles of 10 by 20. But we have 7, even if we do that, we have 7 floors, for 7 slabs discharging. So the idea here was to make something that, well, it's a trick, but that is used in architecture also. So you have the two trusses, and in the floor before, what we did, we skipped them. So in reality, these two floors discharge on these two columns, and these two floors discharge on these two columns. So what we have is the slab is spaced, the trusses are spaced 2.4 meters, but the columns in the facade are spaced 1.2 meters. So each column has half the load it would have if it was a normal structure. And by doing that, we managed to control the size of the columns. Okay, this is something that you probably are not interested, so I'm skipping it. And so this was really the structure. Here you can see that you can see what I mean. You have the columns, the 10 by 20 columns, spaced 1.2 meters, and if you look attentively to the trusses, you see that they are spaced 2.4 meters. Okay, so the challenge here was, okay, building, okay. No, this is important here. So the problem with this lightness, the idea of the lightness has to do with something else. We are in Lisbon. Lisbon is a seismic area, an important seismic area. So everything you can do to make a building lighter helps you in the size, with the size of the cores, because what keeps the building from falling down when an earthquake comes are the cores, those red cores over there. This applies to all the buildings in that high buildings. And here, so the idea of having the building as light as possible was also with this idea that we reduce the forces that are originated by the earthquakes. So here you have an idea of how it was built. So the cores were done up to the maximum height, and the steel structure was coming afterwards. So just an idea of how the composite floors were, and here the construction. So here that's where you see that not all the trusses discharge in the columns in this floor, and then it's in the floor below and above that the trusses shift. Okay, some idea of how the fire protection was done, because at the end it was done with this, painted and black, and so the ceilings are completely black and they are visible. You can look at them. Okay, so this is quite technical, not for you, and an idea of how the structure was. Why did we choose the 10 by 20? Because at the end there was this sun shading elements that are done in GFRC, and they should get into those columns like that. So you couldn't increase the size, because otherwise these elements couldn't have this the same size everywhere. So what you see here is already the columns going up, and on your left you will see the GRC elements. Of course, the 10 by 20 have also a trick. It's just that they are 10 by 20 everywhere, but the width of the plate, as you can see here, the width of the plate is changing from top to down. So exteriorly the column is the same, but internally it, as you are going down, it will increase. So you increase the capacity, the resistance of the column, but you don't increase the size of it, which is what you are worried with, of course. So this is the assembly of the columns, and here you see the 25 meters cantilever that is receiving the whole building so that the cars can come in below. Well, this structure, of course, the load is huge, but this is a structure, you have one floor high, and this is a structure that works with, as you can imagine, here you have tension, and here you have compression, and so there's not much thing about it. And some images of the construction. It's kind of a filigrane. It was kind of kind of strange at a certain moment. The bridge, and okay, let's speed up so that I can show you another one. And this is just already at the end. Okay, the problem here also was that Manuel is a little bit obsessive. So what he did with these lines is that he began with one line in one building. The line went up, went in that direction, came down, went in that direction, came up, went in that direction, and came down. So as a concept, it's perfect. Then the problem, the hell, is to make it happen, because in fact a small mistake creates problems. And this pergola that should have the same size of the rest was a nightmare, because it's 40 meters. These bars, in spite they don't have any load, but they are 40 meters wide, so they have a span of 40 meters. So these blades were also a challenge to put together, mainly because of wind, because there is the problem of vibration on the small side. Okay, finally some images of the end result. The shaders and the plaza and the whole. Here it's when you come down the stairs to enter the building, and here you have the reception. So the floor where all the distribution is done, and some images of the inside, the offices. The idea of having a building that is 12 meters wide is really daylight. In fact, as you can see, in terms of daylight and environment, it's a very luminous space. Auditorium. Well, again, the blades and so on. And finally, the building at night. Okay, then if you have any questions, we can talk about that afterwards. So now I'm going to talk to you about another project with Manuel Aires Mateus, also a competition, one in Lausanne. It's about two museums, Mudac et l'Élysée. Mudac is a design museum. Élysée, it's a photography museum, a very important photography museum. They have, between other things, they have all the collection of Chaplin, of photography of Chaplin. So it's something important. But the big question was, they want a house for two museums that are completely different, because the Museum of Photography, you can't have light. On the Museum of Design, you want lights everywhere so that you can see the pieces like we are here. But the other one, no. So this was the place. The building, the MCBA, it's Musée Cantonal des Beaux-Arts, was already done, was already built. It's another museum, and that was the site for our project. Okay, again, this was the ambition. And the ambition was that we would have a square of 45 by 45 with one museum underground, the photography museum, no light or very low light, and one museum on the top level for the design, and in the middle we would have reception, well, everything you can imagine, shop, cafeteria, everything that is related to common areas in a museum. And this was the idea. this is very nice, but the question was, well, the shape was born of a cube, of stone cube, cut it in a way so that in the middle, with this common space, was just a cut in the two. There's a topography on the ground, there's a topography, as you will see, a topography on the ceiling. Those two topographies, they touch only in 3 points. So you have a 45 by 45 building that touches only in 3 points. So if you look at it, you see that this opening is continuous. You don't have any interruption in the opening. Okay, but nevertheless, this was the ambition for the competition, so that this was the project that they chose. And here you have the foyer where you see what I was explaining, is that you have a topography on the roof, you have some kind of topography on the ground, but the view is completely free. This is one of the points where those two topographies touch in each other. Well, that window is a very good is a very good moment for architects. I'm going to explain to you what happened. Obviously, Manuel had the museum on top completely closed. There was no window. Because obviously in this, I'm sorry, in this kind of volume, you can't imagine a window. How can you do a window in such a volume? It's impossible. So for him, there was no window, it was completely closed. Okay, then what happened is that the client said, oh, no, but I need a window. I want to see the view. The view is beautiful. It is beautiful. The view is beautiful. I want to see And so the struggle was, how are we going to design a window in this volume that doesn't ruin the project? And it was unbelievably simple. And it came from a mind that actually is not even an architect, but he was looking at it and he just said it. The thing was the thing was quite simple. You see that corner on the left? The only thing we did was to push that point up. And when we push it up, you pass the level of the slab, and then you are able to do a window. It's unbelievable. It was really fantastic, because just by doing that, you just push the point, then you go over the slab and you create this triangular window in the corner. It was fantastic, because all of us, including Manuel, we were, what? Obviously, we are saved, and that's why this window is there. Okay, this level is completely has a lot of light, as you can see. The ceiling was done, it's an important feature of the space, because the ceiling is completely has light everywhere, and it's also the duct, not the duct, but the plenum that brings the air conditioning in, as you will see in a minute. Here a section of the model. This building is also, and you will see it from a MEP, if you want, point of view, very, very complex, because the demands of the museums are completely different, not only in the rooms, but also in the warehouses. In the warehouses, you have rooms that are of temperatures and humidity that are completely strict. You can't change them. So the amount of installation and of mechanical things is huge in this project. And joining another problem, we only have 3 points to connect to everything, and well, the placement for the technical areas was obviously a big problem. Here you can see the model. This model, actually it's all in black and white or gray and gray, but you don't see exactly the services, but everything is there. This is a complete model of the building as it has been at the end. And here you can see, well, you can see the rest. The idea of the structure was that we would have a grid. Oh, this is all in quite concrete, as you have understood. So the idea was that in that cavern, if you want, in the middle between the foyer and the MUDAC, we built a huge steel frame, a grid with trusses that do or help, are a part of the structure for the foyer, and to get the loads of the big white concrete walls in the perimeter. So this structure is the main thing. This structure is supported by those 3 points, and this is what supports, well, the whole building over the ground. Obviously, this slab that is in that you have in the foyer, it was used with its capacity of working as a dome, if you want, because at the end of the day, it has that shape. It's not. It has some kind a complicated geometry, but the result in terms of forces is that it can work as a dome. So the steel structures and that slab work together, and that's what gives the stiffness and the resistance to the building. Then you have those walls, and those walls support the roof, which is a shed roof with 45 meter span. The structure on the Élysée Museum, which is the second floor over there, is not as complicated because, well, it's more it has more walls, and so we could use more columns. And then on the bottom you see the level where you have all the warehouses and the depots and everything where the pieces are normally. So this is a section in the other direction. Well, I didn't mention, but it's also important to mention that this strategy of the project is isolated the building of the museums, of the rooms. And by isolating those areas, you had to put offices, administrative workshops and so on around, and that's what you have. What you have here on the left is kind of an annex where everything that is not exhibition spaces is. So you have this idea of annex that is so present always in architecture. So that's what you see here, again, another section. And you have the buildings and workshops here. There, with those arches, you have the restaurant, and here you have the MUDAC, foyer, Élysée. On your right, there is a patio that is where the light comes to the Élysée. Okay, so some pictures more to the annex, the building A, and then the complementary program on building C. Okay, some things boring, white concrete, gray concrete, but okay, you understood that. This is again, this is a part of our project, but again outside. Offices, and this is the main concept from of the structure. There were two challenges here. One was statics. How do we do that? The other one was how to build this, and it was a big challenge, both of them. So from a construction point of view, that's how it was done. You did first the upper part, and then we did the topography below. Okay, this was this is again something interesting. What happened at a certain moment, the building began with concrete structure, as you have on your right, on your left. And this concrete structure, because we are in a very cold country, but at the same time the wall is turned south, so the sun is there very strong. We couldn't have, or we were not willing to have the structure wall exposed to the sun and cold and so on, because that change in temperatures and so on could open cracks in the concrete. And when you are working in a place where there is snow and glass and so on, it's dangerous, because the water comes in, it opens, and the concrete begins cracking and being destroyed. So we didn't want that. So what we had was a concrete wall inside, that was the structural one, and then we had an outside wall over there that was completely free, that could, well, it could enlarge and decrease without having any forces, so without having the danger of having cracks. Okay, typical thing in a project like this, the contractor began raising doubts, delaying, prices were out of budget, and so on. And so we decided, okay, then let's change everything and let's propose a light solution. Well, we just say, okay, we can do that with what they call crépi, with a kind of aqua panel or something like that. You get the same shape, you get the same volume, and we do it like that. Well, that was very good, because it was not accepted, but so it was not our fault. But we proposed to have the building. Of course, the building wouldn't be so strong. Concrete is something that is obviously appealing, and so that solution was developed mainly as a kind of a strategy from our side to make them push us for the concrete, and that's what happened. So the solution changed. We changed the solution for another option. The option that we had, the structure is actually outside, but of course lots of care had to be put to ensure that we don't have cracks. And so we came from this solution, the initial solution, to the final solution there. Of course, the first one had the whole the insulation completely outside, so it was much better. On the second solution, obviously you get cold bridges, and we had to treat the cold bridges, so it was much more complicated. But at the end of the day, that was it has been possible, and it's working. So, well, just for you to have an idea, this is how much steel you get into that. Into those slabs, and this is just a knot of one of the trusses. So this was the sequence of construction. First, we've put some temporary supports for the grid of trusses. Then the grid of trusses, then the cores, and that's how it was until the end. Of course, now I'm going to show it. This is the pre-stressed cables we had to put to control cracking. And okay, so this is just a picture of the roof, of the trusses, and how they enter the cores, because the problem is always when you have steel structures and concrete structures to make the transfer of the forces is always a theme. It's always a problem. So we had to enlarge the concrete over there. Now there we have 80 centimeters wide walls in order to be able to come with the trusses inside. There, the iron, and this is the cavern between the two, the foyer and the first floor. The problem here, this is interesting also for you, because when you enter, you look at the ceiling and it's concrete, and it's you have the shape of the shuttering. But in surfaces like this one, that are like that, you don't have a shuttering, because you can't. The slope is not enough for you to have a shuttering on top of the concrete. So the finish at the end, it's different. So when you enter, what you want it to be the whole thing, it's not the same thing, because the floor is not the same thing as in the ceiling. So, well, at the end, they did a very good job in well, making them as similar as possible. Those props were there until more or less the end. That was the last thing to take out, is because when you take out that's when the structure began working, and it was the last thing. The funny thing here is that the deflections we calculated were not even attained. Not very different, but they were not. Here this picture is funny, because this was the image from the competition, and on your left you have the result at the end. And it's not very far. This is the corner, the free corner, the props. So now this is good for engineers, so I'll speed up a little bit. Okay, oh, this is, okay, now I'm going to speed up just for you to have an idea. This is quite complex about mechanical. I'm going to skip that, but I'm going to show you just one thing. These plans that you will see are defining which area is treated by which air handling unit. So, because the conditions of the spaces were completely different, you had to have different air handling units for each space. And so, as you can see, there's a lot of them. A lot of spaces with different conditions that demanded different treatment. And then we're going to see the technical areas, which is something that you always forget. It's always, you always put the architects always put technical areas in anywhere, and at the end it's a nightmare. And look, this is how full this thing was. Okay, so this is always the same. And this is the only way to do it. The only way to do such a project is with Revit and have everything modeled and check everything in the model, because otherwise it's crazy. You just can't. Okay, this is just to show how the air conditioning of the MUDAC has been done. There are no grills, nothing, because the air comes from the ceiling. Those plates in the ceiling, those white plates in the ceiling that let the light come in, they are spaced, I don't know, 1 or 2 centimeters each one. And the whole thing is a plenum that is under pressure, and so the air comes in. This is when we are heating, and this is when we are cooling. So just coming, okay, some spaghetti, and that's it. No, this was crazy. This project was really something. This was the inspiration for the ceiling. This is the Kunstmuseum by Keretz and Morgan de Gelo. And the lighting also. Well, the lighting is obviously another problem. And the biggest problem was the foyer, because in the foyer you couldn't have anything in the ceiling. You couldn't have projectors or whatever. So how are you going to do it? So we decided to put some totems full of projectors, and tested it first, and at the end it worked quite well. And the light is nice, is very nice. Okay, water, that was a fight again, because we had to put the water inside the space, because there's no way we couldn't have the pipes outside. So what could we do? But it was a fight with the Swiss, yeah. Okay, so final models, and that's it. Final images with the lighting poles, the stairs coming down and up, the big room, and the window. Okay, so that's it. Are you sleeping? No? Not yet? Okay, I'll put you to sleep now. Then, next one. This is another building for the EDP electrical company. So, but this one is a continuation of the first one. It was done with Elemental from Aravena, Alejandro Aravena, and it was a problem from an architectural point of view, because when you arrive and you have something like the other one, as you have seen, you have a situation. How am I going to respond to that? Because in fact, that's what it is. So the other building was quite light. It's all about lightness, and so Alejandro decided to have something more in his line, heavy. And okay, so the idea, his idea, was to respond to that plaza, the same plaza, to do another plaza, but with a completely different feeling. While you have one plaza that is light, completely, volatile if you want, well, he decided to do something much more heavy, with concrete, and with a kind of concrete that is the kind of concrete he uses. We tried to do the kind of concrete he uses in Chile, which is a not so sophisticated kind of shuttering, so that you see the wooden planks and so on. But so this was his idea, to do a very heavy plaza and then open the offices to the exterior. But the idea and the concept is exactly the same. You have two parallel blades connected, not in a level, but connected at ground level, as you can see there. And then you have, below, you have the car park as the other one. This is not so high, so this is 1, 2, 3, 4, 5 stories high. And what can I say here? Not much more. Okay, so there what we see is really the idea of the concrete, his idea of the concrete, that is a very rough concrete that sends us to something very powerful. Okay, some plans. Here you have the ground floor with the connection between the two. Obviously here, you will see there the entrance. There is one entrance is on the top left of the drawing. You enter over there, and then you are distributed again for course. The plans, all the services are concentrated in this strip, in the concrete strip, if you want. And then after the concrete strip, you have the light building, not so different from Aires Mateus building. But all that, everything is there, toilets, technical rooms, even some meeting rooms, lifts, and so on. Okay, so here the issue of the services was also quite complicated, but well, as we had the other before, and here we had more height because we only have less floors. Well, it was not so complicated as in the other one, but it is a little bit. So here it's all about coordination, design, coordination. Again, and here it's already to the logic. The logic of the building is more or less the same. What we have is these trusses that worked very well at EDP, so we repeated those. They were used to that, so we did the same, and all the services are visible on the floor. The air conditioning system is different. It's these chill beams, active chill beams, and of course the rest of the project is this is ground floor. Again, for the structures, so here the question was, okay, as we have those huge concrete strips, well, the building for horizontal forces is perfect, no problem. So the question was the rest, only the rest, because those cores are strong enough to take care of horizontal forces. Okay, the boring part. Okay, so excavation, and this is just a sequence of construction. Okay, so here you see that the connection between the two buildings is a kind of a tunnel, a parabolic tunnel that connects the two buildings, and it's put in a way that that thing over there, which is kind of a mirador, kind of a sightseeing place, it goes over and it's supported actually by this tunnel. Some pictures of the basements being built. Oh, here, the funny thing here is that Alejandro played a little bit with the way he builds in Chile, because obviously South America is kind of different in terms of construction. There are lots of demands that in Europe we have. Well, some countries more than others, but there are lots of demands that for them are not important at all. So here it was planned to have an interior wall in the excavations, in the basements. But when they excavated, well, they looked at it and said, why don't we leave the walls visible inside? We just do some kind of gutter or something for the water that may appear, but let's leave it like that. And at the end of the day, that's how that's how it is. It is, and actually, it's beautiful. So some construction, not so nice. Here you see that it's exactly the same system as the other one with the trusses, and the slab just under the false pavement, the pavement that covers the building. And here you begin looking at the result. The idea of the columns is exactly the same. This is also the same size, 10 by 20. And okay, services. And here you have this cantilever, this big cantilever that is being supported in two moments, and it's a kind of a mirador inside the plaza. The tunnel, and here the slab is not yet the landscape is not yet done, so it's quite high. And these are final pictures. The other question, the other challenge for us here was this volume, because again, Lisbon is a seismic area, and this volume, this mass vibrating at that was a problem in terms of touching the other building. So this is during construction, and this is exactly that corner that, well, supposedly touches the other volume. And this, from a structural point of view, that was also a big challenge. And as you can see, well, it's not a point, but it's not so bad. Okay, so this some technical areas for you to see, and this is as you can see, the concrete walls are visible, and it's quite funny. The only thing I'm not talking here, because actually I don't have those pictures, but on your left you see this wall is completely covered with tiles, Portuguese tiles, and what they did. But not only this wall, even the lift shafts are completely covered with the tiles. And what they did, because they are done by the best company, which is not cheap, but what they did, they chose the ones that were there for ages that nobody wanted. So he chose all of them, and then with them he did kind of a patchwork. And it worked quite well. And actually, it's interesting when you look at the shaft and you see the whole thing covered with, because the lifts are in glass. Okay, so now the plaza, that point, this is the entrance, as I've said before, and picture of a drone anywhere. And the two, and that's it. Okay, so 42. That was it. It's like my computer, it's the same problem.
Yeah, thank you very much for the interesting lecture. I was wondering, if you were to go back in either of these projects, is there something you would defend as an engineer to the architects? Like a specific...
I'm sorry, I didn't get it. Is there something?
Is there something that you would defend as an engineer to the architect, like a specific element of the project that would also reflect its design?
That reflects his design? Well, look, the question is always the same.
Yeah.
When you go for projects like this one, I'm sorry, I have to pick this up because I'm not happy with this. Okay. With projects like these ones, like for instance, Lausanne or EDP headquarters or even MAD, the beginning of the project is the beginning of an adventure. And the only way you can get to the end and have a good result is if everybody is like that against everybody. But the team needs to be like that. So everybody has to be fighting for the concept, the idea, and of course there are fights inside some fights inside the team, but that's not relevant. What matters is that we are all defending. For instance, you saw one of the things you saw in Lausanne was that change that was proposed in the walls. And for instance, that was mine. And at a certain moment, I said, Manuel, we are dead if we don't do this. So we have to do this and trust that they will skip that. And that's what happened. It was very successful because there was a problem of cost, time, delay, and so on. And we were being squeezed. And so there was this strategy. Okay, we do something light, we do something fast, and at least we've put an alternative on the table. And that was it. So I think the whole process is about defending the solutions of the project, and the solutions of the project are not the solutions of the architect or the engineer or whatever. We are defending the project as a whole, and the concept behind that project. And of course, during the construction, and even, mainly during the construction, there are plenty of ideas and suggestions that come from everywhere that ruin the project without even understanding that they are ruining the project. So this whole process of defending it, it's something that, needs a lot of resilience, and a lot of, power of communication, seduction, a lot of things that you learn. But I think I said the main word. Of course, when it comes to money and time, seduction is a difficult word because nobody wants seduction when we're talking about that. But to seduce the client to the idea, to the concept, and to the project, that's one of the most important qualities of an architect. Once I saw an interview by Cisa talking about Eduardo Soto de Moura. And, he said, okay, he's my friend, and they said, the biggest quality of Eduardo is his capacity of seducing the clients. Is his capacity of selling his idea in a way that the client will defend it even more than him. So that's and it's true, actually. It's true. It's because he's really convincing when he's selling the idea. I don't know if I answered your question because I didn't have it completely, but I hope I did.
No, you didn't. Thank you.
Maybe a follow-up to that question. I'm wondering if you could talk a little bit more about when you entered the team for those projects, or how the architects, consultants, engineers, how was that team building like? And especially in terms of projects that are growing ever more complex with more specialties and more consultants and all of that.
Well, I think I said I said it in a way in the beginning. All these projects go a little bit beyond what these architects do in their daily life. So if they want to do something that is sensible, they need us straight away. So all those projects are projects that we enter in the architectural concept. And that's, of course, that's what I like. That's what I love to do. And at the end, it works, because then the team is really built in that way. But for instance, I'm talking about now, we are doing with Aravena, again, a tower in Basel, in Switzerland. And it's exactly this. Their concept is being bombarded by everybody. And we are there with them, and we are all together, just waiting for the balls to come to prepare. How are we going to do and to adapt to because there are constraints and things that are set to us that make sense. So that sometimes we have to say, look, they are right. So we have to move. So that process is the biggest, one of the biggest things for the team building, because put everybody together as a tribe and defending from the enemy. But that in all the projects I have, it's all about that. When you're talking about this kind of projects, because of course there always someone that will come and say, this is too expensive, we can't do this, we have to save money, or it takes too long, and things like that. And nobody knows how it was built. All these kind of questions that always happen. And at the end of the day, they are not true, but we have to deconstruct the whole thing. Well.
Hey, first of all, thank you for the lecture. I wanted to ask a bit about how is your approach towards the exploration of materials in such ambitious and high scale, big scale projects, also in relation to the economy of materials or, yeah.
Okay, now I have a complaint then. Okay, your question is perfect. The moment we live, not now, already for, I don't know, some 20 or 30 years, is that we have to save materials, we have to think well about what we're doing with concrete, we have to think about sustainability, energy efficiency, and so on and so on. Okay. In my life, who are the biggest enemies of everything, of all what I've said? Architects. Oh, but concrete is so nice. No, let's do it in concrete. Concrete is stupid. We can't do it. No, but it's, you know, it's heavy. It's, you know. Okay, let's do it in concrete. Okay, but you see the kind of thing. it's always about that, because I think that's me thinking. I think the problem with aesthetics is that for us, it's beautiful what we know, what we identify as beautiful, what we know, what we saw, and we were raised on that. And so everything that changes is somehow not nice or not so nice, or mainly for when we talk about buildings and so on. And so I think that this takes time. It will take time. Again, the other problem is constructors, builders. It's the most conservative industry in the world. It's construction. I remember, and this is a southern reality from my country, when I graduated in '82, the plasterboards were appearing. And as a young engineer, I looked at it and said, this is genius, because what do we want in a wall? We want a white plan. So with this, we do a white plan in 10 minutes. It's fantastic. Do you know how much time it took for a plaster wall to be at the same price as a brick wall? 30 years. Well, not 30, I'm exaggerating. 20. It's crazy. So, things that are obvious in the construction industry, that you look at them and they are obvious, it's a nightmare to make the construction industry change, because it's the way they are used to do. And with architects, I think it's a little bit the same thing. The schools where, for instance, the Portuguese school, I'm not even going to other places, but Portuguese school is based on this idea of weight and well, it's like the three peaks, to have something that weights and it's strong, and it doesn't make sense anymore nowadays. It may make sense with the 3D printers and so on, that optimize the amount of the quantity of concrete and so on, but it's not about that. It's about really the question of embracing the new things, and let's work with them and do fantastic things with them, because otherwise we'll be calling moderns in 50 years we'll be calling moderns again the moderns of 100 years ago, and it can't be. We have to overcome that, and that's it. We are always talking about modernists. Modernists, that's 100 years ago. What are you doing? Let's move on. We have to move on. It's fantastic. One day, that this is, well, now just a side talk. One day I decided to do something to make a provocation in a school of architecture, and I've picked the images of houses. No, of a telephone 100 years ago, a car 100 years ago, a train 100 years ago, a plane 100 years ago, and a house And now, a car, nowadays, a plane, a telephone, and a house. And you look at both and said, what's going on? It's unbelievable. We're doing exactly the same thing in terms of, even in terms of construction. You look at the Tugendhat, and the Tugendhat is high tech for nowadays. So I think the construction industry was not able to move forward yet. It has a lot, and you look at the phone, well, imagine 100 years ago thinking even about this. So a phone was something really complicated, or a train, or whatever. And it gives us something to think when you look at these two moments in history. Okay. Something else? Okay. So let's go.